Today, Carlotta and I will be talking about supercharging your data science projects with GitHub tools. And let me introduce myself. So my name is Gabriela de Queiroz. I'm Director of AI working for the Microsoft for Startups, but my background is all in data science, and Carlotta used to be a colleague of mine. Carlotta, do you want to introduce yourself?
Yes, of course. Thanks, Gabriela. Hi, everyone. I'm Carlotta Castelluccio. I'm a cloud advocate, and I'm focused on artificial intelligence and machine learning technologies. And I'm thrilled to be here today talking about GitHub tools and how to leverage them in your data science projects.
Awesome. So let's go to the next slide. I want to talk a little bit about how AI is changing the way we work. So as we know, like technology is advancing in this very rapid pace, bringing new innovations and transforming our workplace. And one role that is being especially disrupted by these advancements is the data science role. So with the help of these new technologies, data scientists, we can work faster and more efficiently than ever before. And I will start sharing some numbers just to give some motivations around one of my favorite data science tools, which is the GitHub Copilot, that we are also going to be talking about that today. So over 1.5 million developers have adopted, and they love Copilot since it was first introduced. In the Stack Overflow 2023 developer survey, GitHub was the top choice among developers for those already using AI developer tools, with 55% of the vote, so more than the majority. And for those that have not yet adopted, 75% of the developers want to try Copilot in the next year. And why is that? It's because Copilot allows developers like data scientists to code 55% faster, and 75 feel more fulfilled by using this tool. So you can use GitHub Copilot with your favorite IDE. I have my favorite one, which is the VS Code or Visual Studio Code. But if you haven't heard about Visual Studio Code, I will just give you a walkthrough, like how it looks like when you open. And especially because today we are going to be talking about all these tools, and we are going to be showing VS Code as well. So as you can see, as a data scientist, one of the main things that we use is like Jupyter notebooks or IPython notebooks. And on the VS Code, I really like the way that the IDE is organized, because on your left side, you have this kind of like menu bar with a lot of functionalities, like you can have the GitHub integrated, so you can do pull requests, clone repos, and so on. And there is other extensions that you can also like install. Like in that case, in my menu bar, I have not only GitHub, but I have Azure extension. I have GitHub Copilot Chat. I have this one is not showing, but I even have R, so I can use R within my IDE, my VS Code environment. And you can also connect to Code Spaces, which is another tool that we are going to be talking about today. So I'll pass to Carlotta, who will give us a lot of like more deep details around those tools.
Thanks, Gabriela. Thanks for introducing these great tools. And I definitely believe, as you, that Visual Studio Code, GitHub Copilot are two of the main ingredients of the secret sauce to the data scientist productivity boost these days. But for those of you who don't know what GitHub Copilot is, how to use it, or maybe you just didn't have the time to test the newest features, let me dive deep a bit into it. So last week, it took place the biggest GitHub conference, which is called GitHub Universe. introducing lots of great announcements. And I was personally impressed by a quote from the GitHub CEO, Thomas Donk, because he said that just as GitHub was founded on Git, today they are refunding the company on Copilot. And I think this already tells everything about how powerful this tool is and how much AI will change our daily job as AI engineers, as data scientists, as developers. And I read in this quote that GitHub was born as a versioning system, but it evolved a lot since the beginning, and it's now much more than that. So talking about GitHub Copilot, Copilot is an AI-empowered paid programmer, which basically offers autocomplete style suggestions as you code in different languages. And as Gabriela mentioned, it's also currently the world's most widely adopted AI developer tool. So it helps you code quickly and more efficiently. If you have ever pair programmed with a colleague, you can grasp what I mean. You are very much more productive when you have a colleague to pair program with. But Copilot is more patient than your colleague and also available 24 hours a day, right? So you can receive suggestions from GitHub Copilot either by starting to write your code or also by writing a natural language comment, for example, describing what you want your code to do, and have GitHub Copilot convert the natural language description into code, for example, Python, R, JavaScript. So what's the difference with other completion tools like IntelliSense, for example? The key point is that GitHub Copilot synthesizes the code using its training set and your project context. So Copilot knows about your project structure and all the code you have open in your project. And it also understands the history of actions you have taken and code you have written in a project and uses that as data to inform its prediction. Again, as Gabriela mentioned, it's available as an extension in the most popular IDEs like Visual Studio Code, JetBrains, and it is powered by a generative AI model developed by GitHub, OpenAI, and Microsoft. GitHub Copilot is trained on all languages that appear in public repositories. And for each language, the quality of suggestions you receive may depend on the volume and diversity of training data for that specific language. For example, Python is very well represented in public repository, so Python is one of the GitHub Copilot best supported languages for this specific reason. And languages with less representation in public repositories may produce fewer or less robust suggestions. But still, it potentially can help you on every existing languages in public repositories. But let's now go the main capabilities of GitHub Copilot, because I started to talk about just the very first one, so inline suggestion, which is the capability, the first capability when it was first released in 2022. So it was the main functionality when it was first released. But in 1 year and a half, our AI pair programmer has evolved a lot, becoming able to support us throughout the whole project life cycle. So, for example, Copilot is now able to help us with the project setup by creating a workspace according to a natural language description. It is able to support us in code writing, but also with code debugging and error troubleshooting and fixing. It is able to clarify code shared from other collaborators, for example, and also document our own code. It is able to suggest relevant descriptions for our PR messages that we always don't know what to add in our PR description, right? Or help us with creating unit tests. And also in every phase of the project, we can directly interact with our assistant through a chat interface, so in a very natural manner. And we can ask code-related questions related to tools, or for example, question related to VS Code and how to use it, or to explain, we can also ask Copilot to explain a machine learning concept. So to start using GitHub Copilot, you need to sign up for it with your GitHub account. So if you don't have a GitHub account, you need to create one and then sign up for GitHub Copilot. And you can start also with a free trial. Also, if you are a student, an educator, or if you are a maintainer of a popular open source project, Copilot is free for you. So I definitely encourage you to claim your benefit if you are in one of these categories. Then to enable it in Visual Studio Code, for example, since we are going to showcase it in practice in Visual Studio Code, you need to download a couple of extensions to use it, which are called indeed GitHub Copilot, and the other one is called GitHub Copilot Chat, and enables the chat interface I was referring to previously. And talking about GitHub Copilot evolution, last week during GitHub Universe, some great announcements have been made on this topic. I don't know, Gabriela, what was your favorite one? But I picked three of the great announcements they have done. Like GitHub Copilot, now available on github.com and on mobile app. GitHub Copilot Enterprise that has been introduced as an additional type of subscription, which basically enables a personalized Copilot to your organization. So you can augment the model behind Copilot with your enterprise data, like private code base or other data sources. And coming next, we'll be having also GitHub Workspace. And this feature, which will be powered by OpenAI GPT-4, will enable GitHub Copilot to generate and propose a project plan to implement an intended change, starting just from a description of a GitHub issue, again, in natural language. And this is not an exhaustive overview of the announcements. It's just my three takeaways. Gabriela, I don't know if you have anything to add here that you were particularly impressed of last week.
Yeah, I like this one that you have the GitHub Copilot in the browser on github.com. And the other one that I think is going to be so helpful is the PR one, where it can help you writing the PR and summarizing what you just did, because it takes us a lot of time. If you want to create a well-written and summarized PR, it takes some time, and this is going to save so much time that I can't wait to use these tools.
Absolutely, I 100% agree. But let me just do a small but essential note here before moving ahead, because GitHub Copilot offers suggestions from a model that OpenAI built from billions of lines of open source code. So as a result, the training set for GitHub Copilot may contain insecure coding patterns, bugs, or references to outdated APIs or items. When GitHub Copilot produces suggestions based on this training data, those suggestions may also contain undesirable patterns. So it's important to be aware of and be cautious about the limitations of the service that you can find in transparency note, in the transparency note of GitHub Copilot. And it's also important that, like any other code you find on the web, the code suggested by GitHub Copilot is carefully tested, reviewed, and vetted by you. Remember that this tool is a co-pilot, you are the pilot, and as a developer, you are always in charge of the quality of the code you produce, with or without an AI-powered tool. So now Gabriela mentioned another great tool in the GitHub in the GitHub ecosystem, which is GitHub Codespace, that I wish to introduce you before going into an hands-on demonstration. So a Codespace is basically a remote virtual development environment hosted in the cloud. And this could not sound very innovative to some of you because it might recall other existing container solutions like Kubernetes or Docker. However, the difference is that Codespace also provides a seamless attached text editor, which by default is Visual Studio Code, and which is accessible either through the VS Code local desktop app, but also via a web browser. So you can basically work on your project just with a web browser without having anything installed in your machine. And if you choose to use the desktop app, there's a handy GitHub Codespaces extension to install in Visual Studio Code. So creating a GitHub Codespaces starting from a GitHub repository, hosting your code is a matter of few clicks. And I show it in practice, but for now, let me share that when you create a new code space, you can define a few configurations of this remote development environment, like the branch of the repository you want the code space to be created on, the cloud region, and you can also choose from a selection of virtual machine types from 2 cores, 8 GB RAM, and 32 GB storage, up to 32 cores, 128 GB RAM, and 128 GB storage. And also the very added value, I think, it's that you can configure the dev container configuration if you wish to customize your development environment. But before going into the dev container configuration, Gabriela, is there anything you want to share about CodeSpace that you really like a lot?
Yeah, it's the second tool that I like the most, CodeSpaces, and I really like the comparison especially when we are working in Python, and it's such a pain to create a Python environment, especially when we are trying to reproduce, when we are collaborating, and you want to reproduce the same environment that I have with the same packages. We joke that it's like, oh, it's working on my machine, so it should work in yours, and that's never the case. But with the CodeSpaces, you don't have that issue, because you are going to replicate the same thing that I have on my environment. It's going to be the same on yours. So it's amazing that you can do that nowadays with CodeSpaces. The other thing that you can do, what you were saying, you can use the web browser. You don't need to install anything from your repo. You can create the CodeSpaces, and everything is going to be there for you already ready and set up to start doing your work.
Awesome. Thanks for sharing, Gabriela. By default, a code space is created basically from an Ubuntu Linux image that includes a selection of popular languages and tools. But something I really like about this service is that you can really customize your project for a GitHub code spaces by simply committing configuration files to your repository. And this, as Gabriela was mentioning, basically creates a repeatable code space configuration for all users of your project. So no excuse that this is working on my machine but not in yours. The configuration files for a dev container should be contained in a folder called .dev container in your repository, and the primary file in the dev container configuration is the devcontainer.json file, which basically include the frameworks, the tools, the extensions you need to use in your project. And then this file also usually contains a reference to another kind of file, which is the Docker file, which is a text file that contains the instructions needed to create a Docker container image for this code space. So you can define a single dev container configuration for a repository, different configurations for different branches, or multiple configuration according to your needs. It's very flexible. So another thing I want to share with you is what is the life cycle of a code space. So the life cycle of code space begins when you create the code space itself and ends when you delete it, right? And you can disconnect and reconnect to an active code space without affecting its running processes. So you may stop and restart the code space without losing the changes you are working on and that you have made to your project. But let's see step by step in this timeline. So we say that everything, of course, starts with creating code space. So you can choose to create a new code space from a branch of your repository each time you're developing GitHub code spaces, or also keep like a long-running code space for a single feature. And also, when starting a new project, you might want to create a code space from a template and publish to a repository on GitHub in a later moment. If you choose to create a new code space each time you work on a project, you should regularly push your changes so that any new commits are on GitHub. While if you choose to use a long-running code space for your project, you should pull from your repository's default branch each time you start working on the code space in a way that your environment has the latest commits, so it's synced with your remote clone. And be aware that there's a limit in the number of code spaces you can create and run all at the same time. So if you reach the limit, you will see like a warning message that alerts you that you have too many code spaces open at the same time. So let's talk about saving changes, because this is probably very important. We don't want to lose the work we are doing on our project, right? So when you connect to a code space through the web, the auto-save feature is enabled automatically for the web editor and also configured to save changes after a certain delay. When you connect to a code space through Visual Studio Code running on your desktop, you must enable this auto-save feature. Your work will be saved on a virtual machine in a cloud, and you can close and stop a code space and then return to the saved work later. But if you delete the code space, or if, for example, it expires because there's a timer configured, your edits will be deleted too. And so that's why it's very important that to persist your work, you need to push them to your remote repository, as you usually do to persist changes when you work on your local clone. Also, when you implement changes to your dev container configuration, you need either to create a new code space or rebuild the existing one to have them applied. So after you have saved, there's the stop step, let me say. When you stop a code space, any running processes are stopped and the terminal history is cleared, and any saved changes to your code space will still be available when you next start it. But if you do not explicitly stop the code space, it will continue to run until it times out for inactivity after a timeout, which by default is 30 minutes. Only running code spaces incur in CPU charges. And then we have the delete option. So another way to optimize your quota usage is deleting a code space. For example, you can create a code space for a specific task and then delete the code space when you have pulled all the changes you want to do for that specific task. If you try to delete a code space with unpatched Git commits, your editor will notify you that you have changes that have not been pushed to a remote branch in a way that you cannot lose your changes. So GitHub code spaces, in particular when coupled with dev containers, allows you to start coding faster, basically, enabling a new way of coding and sharing your demo code or collaborating with others on the same project. And in this deck, you can see the old way and the new way of contributing to a repository, starting from an existing one. And the first thing that catches your eyes is how long is the list of steps in the left panel and how short is the list of steps in the right panel. And in particular, you can notice how in the old way section, the start coding step is here at the 9th position, while in the new way, it's at the at just the 3rd position. So this simply proves how much code space allows to reduce the complexity of coding and contribute to a repository with respect to the past, resulting also in a significant time saving. Now, how you can get GitHub code space? All GitHub users can access GitHub code spaces for free with a personal GitHub account with a limited quota, which is 120 core hours and 15 giga memory each month. And additional usage incurs into cost according to a pay-as-to-go approach. And there are specific benefits again for verified students, verified educators, and owners of big open source projects. So if you belong to any of these categories, please check them out. Great. So I think I've talked a lot, right, Gabriela? Maybe it's time to show some hands-on demo to put these things into practice. So let me jump into Visual Studio Code for that, and to see in action the tools we have presented so far, and explore how you can really leverage them in your data science project. Let's imagine we have been asked to create a predictive model to forecast the number of rentals for a bicycle rental business, for example. And you should base this model on seasonality and weather conditions. So to build such a model, starting from an historical rentals data set, we're going to perform some data analysis and data experiments in a Python Jupyter Notebook in Visual Studio Code. So let's think first, when we open Visual Studio Code, we have, of course, a blank space, an empty workspace. And I believe that starting a new project and setting up everything we need to work, probably it's the hardest part, right? When you start doing a project, then things roll out smoothly. An empty workspace might be really intimidating. So before we can start writing our first line of Python code, or even start creating a new Jupyter notebook, here we would need to have the last version of Python installed on our local machine, and then the Python and the Jupyter extensions installed in Visual Studio Code. And that's not all, because then we also have to install the Python libraries needed to explore, to clean, to visualize the data, and the ones needed to train and to evaluate our machine learning model, right? So lots and lots of prerequisites to install and to configure. And also, this set of prerequisites may vary from one project to another, and some of them might have conflicts and dependencies requiring some additional efforts to our workflow. And of course, if we collaborate with a team of colleagues on the same project, they should replicate the same installation process to be able to contribute to our code. But hey, don't worry, we are in 2023. We have AI, we have GitHub Copilot, we have GitHub Codespaces. So once we have enabled GitHub Copilot chat in Visual Studio Code, we can interact with this built-in virtual assistant through a chat interface. So let's open this chat that I mentioned with you before. Here's my chat interface with my AI pair programmer. And then I can ask questions in natural language or using a specific feature which is called chat agent. So you can think of an agent as basically an expert. We can ask for support on a specific subject. So similarly to when we mention a user in the chat, we can use the @ symbol to mention our chat agent, our expert. And also to further define the scope of our request to the agent, we can also use a few /comments. But let's do an example. So here I have an empty workspace, and I want Copilot to help me setting up a few things. So the agent I can ask support to in this case is the workspace agent, which basically does this work. And then the / command I can use is the /new command that really is used to scaffold code in a skeleton template. And then let me also add some more details on how I want this workspace to be. So I want a new workspace for a Jupyter Python notebook with the GitHub Codespaces configuration, which installs 3 very common data science libraries for Python, which are pandas, NumPy, and scikit-learn. So let's see, let's ask these questions, let's do this request, and let's see GitHub Copilot response. Great. So basically, GitHub Copilot output is a suggested directory structure from my project. And you can see that these include, for example, the dev container.json, I've mentioned it beforehand, which is a configuration file for the GitHub Codespaces development container, specifying the Docker file to use, to create, to build the image, and also the extensions to install in the dev container. So you can see here you have the Docker file reference, you have the settings, you have the extensions, and so on and so forth. And then what else do we have here? We have the Dockerfile folder, which is a placeholder folder to add a Docker file containing additional instructions needed to build our container image. We have, for example, the requirements.txt file, which is a file listing the requirements for my project. Since in my request, I explicitly asked for pandas, NumPy, scikit-learn, I have those 3 here. And since I've mentioned that I want to use a Jupyter notebook, I also have Jupyter Lab here. And then, for example, it was able to create a Python Jupyter notebook for me. Of course, this is a template that I can customize as I need. It's still like a good starting point for me to start my project. In fact, you see that I have the import of some libraries. I also have an example of importing to loading a data set. So I really have a good starting point for my project. And it also created a README file with some description of my workspace, basically. And also by clicking create work, so not only it suggests me this directory, but by clicking create workspace, the directory structure will be created locally, so actually created on my machine. And the files that you have seen here, initialized with some basic content that we can customize for our scenario, will be really created. So basically, we have a project skeleton that we can use to kick off our project, which is much better than starting from a blank space, right? But now let me jump into my project, the project I have customized starting from this this initialized template, because I want to show you some other cool stuff. As I highlighted before, GitHub Copilot with the workspace agent has created some placeholder files that I customized for my scenario, right? So in my example of the data science project to forecast the bicycle rentals trend, I added, for example, a Docker file, installing, defining my dev container image. Then I customized the list of extension, for example, in the dev container. I added a Jupyter extension that I need to execute the Jupyter notebook in code space. I added Copilot chat and Copilot extensions because I want to be able to use these extensions also in my code space. So as soon as I launch my code space, I want to have my virtual assistant with me. And I also customized the requirements.txt file, adding some other extension I will be using, like IPyKernel, Matplotlib. And another thing I've done, of course, is filling in my Jupyter notebook. If you remember, we had just the first code cell, code chunk with some libraries import and the loading of a placeholder data set. Here I have my code. And before going into the details of this notebook and what it does, let me do one thing. Let me create a GitHub code spaces to execute this code based on the configuration files we just explored. And to create a GitHub code spaces, first thing first, you need to have your code on a GitHub repo, on a remote GitHub repo. So you need to create a repo and initialize it in a way that it hosts your code remotely. And you can do that directly on github.com if you'd like, or you can use the Visual Studio Code built-in features by clicking here on the source control button. So you can see here that I already have connected a remote GitHub repo here, which is this one here. But if you don't have any linked remote repo to your project, you will be having a simple button with named like initialize your project on GitHub. So with one click, you can do the initialization. And you can follow the step of the graphical user interface to choose the name, to choose all the characteristics of your repo. So when we have our code on a remote GitHub repo, the other thing we can do is again asking support to our assistant in the chat. And this time I want to ask how I can build a GitHub code spaces starting from this point, so starting from my configuration files. And this time I will be using another agent, another expert. So I will be tagging an expert called VS Code that basically it's there to really help me on everything around Visual Studio Code. So for example, in this case, I will ask him this question here. How can I create a GitHub code spaces on top of this repository using Visual Studio Code? Let's see if it can help us to accomplish this goal. Here we are. So to create a GitHub code space from a repository, I need to follow this step. I need to open the command palette to select this command. So let's really do that. Let's open. Oh, sorry. Let's open the command palette. You see I have the code spaces, create new code space command here, and then I can select the remote repository I want to build the code space on top of. So you can select your repository, of course. So you can use the step-by-step procedure to finalize the creation of your code space. The code space will take a few minutes to launch according to how many prerequisites you added. So how many prerequisites it needs to install in the code space. So that's why I already created one here to not waste time. So I have my code space attached, and you can see it also from the Remote Explorer tab. You can see the GitHub code spaces that you have attached. In this case, I have this one. That means that I'm ready to execute my Jupyter Notebook because I have a development environment configured and ready to execute my Python notebook. So let's run it, and let's have a look to the Python code. So first of all, you can see here that the kernel is already defined, and as soon as you will open your Jupyter Notebook in a code space where you have configured everything beforehand, you will have your kernel already there and ready to execute your code. And this is a very simple Python notebook with a few code chunks. Just for our example, you have the import of the required libraries and the import of the data set, which is the history of the bicycle rentals. Then you have some data visualization, for example, and you also have the training of a linear regression model to forecast the bicycle trends. And finally, that's the evaluation piece of the train model. So after the evaluation piece, let's add another piece of code. For example, let's imagine we want to visualize the difference between the actual and the predicted values with a scatter plot, in which we have the actual values of the daily bike shares on the x-axis and the predicted values on the y-axis. So let me start adding here PLT, which stands for plot, dot, and as soon as I start typing, you can see that GitHub Copilot starts suggesting me the completion of the code. And by going over this gray suggestion, basically what I can do is accepting the whole suggestion, accepting a portion of it, like word by word, or of course I can also ignore the suggestion and go ahead with the code I want to write. But let's accept the suggestion. Then you see it is suggesting me also to name the X label, the Y label. Let's see, and then the title. Awesome, yeah. Then I have the code to create my polyfit. So my diagonal line. Okay, now the suggestion, so I will go ahead and finalize my code. So let's do the plot itself. Y-test is my array of actual label, and then I have my predictions. Sorry, let me do one thing in a way that we can optimize a bit the time. So I complete my code here. I create my plot. I do plot show, and let's run this. Okay, I have my graph, right? So I showed you how Copilot is suggesting me, is helping me with the code, but I want to show you another thing. Let's imagine that by writing my code, I did a typo. For example, here I missed one S, right? And I don't realize that I have this error here, and I run the code. Of course, I will get a name error because this error with this array with this name is not defined anywhere, right? But what I can do here, I can help ask again help from GitHub Copilot, this time with the one-click button. So I can click here the fix using Copilot button. And what basically happens here is that Copilot is suggesting me the fix with this view with my code and the edited code. So in a layout in which I'm very familiar with if I'm used to use GitHub. And then I can accept the fix. And if I run again, this will be executed successfully. And the same thing, I can do the same thing by opening my inline chat interface with Control-I, and then using the /fix command. So I can either use the /fix command or the button here. Anyway, I will have my paid programmer troubleshooting the error with me and suggesting a fix. So this is already quite cool, right? But once our code is fixed, there's another challenge we might need to face: documentation. So drafting clear documentation for our code is essential to make it readable when shared to our collaborators, customers, and even for our future selves. Again, we can accelerate this tedious and time-consuming process through GitHub Copilot. So by selecting a piece of code we want to document, so let's imagine we want to document this piece of code, we can then add again, open again our chat window, and then use another / command, which is /doc, and request GitHub Copilot to document the code for us. So you can see here that it is writing a quite accurate and detailed description of my code. So really line by line what is happening here. And one thing I can do, for example, is that I can copy this description. And since I'm in the Jupyter notebook, I can use this as the content for my markdown cell. And here we are. I have my description of my code, which is quite detailed. Of course, I need to review it. Now we don't have time, but I need to carefully review it, change everything that doesn't work. But still, I have this will help me to be much more productive in my documentation task. And that's another painful moment, right? When you save here your notebook, and you have your changes here to pull to your GitHub repository. Another problem is the message of the PR you need to add. Mm-hmm. And again, you have GitHub Copilot to help you here, and you see that it already auto-populated the PR field with what I've just done. So fix the name error in scatter plot code. And if I click again on this button, I get other suggestions. So this is another very, very helpful thing. So I don't need to spend time in thinking what I need to write in my PR message, because I can have suggestions from GitHub Copilot. That's it for the demo. I don't know how much time we still have, Gabriela.
I think we are just right on time.
Awesome. So I come back to the deck just to conclude here.
Yeah, and I shared with everybody the blog that we have, and also like where the demo that you just showed, the GitHub repo, so you can all access the two materials that I shared. But before we finalize, I just want to share a little bit about Microsoft for Startups Founders Hub, which is a platform that everybody can sign up if you have an idea or if you already have a startup. And the cool thing is like you get up to 150,000 on Azure credits that you can use around any Azure service like OpenAI, Azure OpenAI services, which has the same APIs as the OpenAI, but also you can get free credits with OpenAI. The other piece that I really like is the one-on-one advice from Microsoft AI experts. So you can schedule calls with AI experts to talk about either a problem that you are having or to brainstorm some ideas for your startup. And you get a bunch, like a lot of like different tools, not only Microsoft tools like GitHub, Microsoft 365, LinkedIn Premium, but you also get access to other tools like Miro, Stripe Atlas, and so on. So you don't have to have a startup, a funded startup or incorporated startup. You just need an idea, and the sign up process takes you like 5 minutes. So I would recommend everybody to go and check and take advantage of like the free credits. And the last slide, just want to share like again the resources, but I shared on the chat. So we'll be on the blog post, there is everything that Carlotta just mentioned, all the demo, all the pieces and additional resources. And unfortunately, we will not have time for questions, but feel free to connect with Carlotta and I. And I want to thank you, everybody. I don't know, Carlotta, if you have any last remarks, but I want to say thank you.
Yeah, no, I just wanted to add that I'm in the Funders Hub expert network that Gabriela was mentioning. So if you get accepted, you're already in the Funders network and you would like to connect with me one-to-one, I'm happy to support you and to have a chat on everything related on AI. So and also if you are not in the Funders Hub network, you want to reach out directly with questions about this session, feel free to do that.
Awesome. Thank you.
Thank you so much. Thanks for joining.